Welcome to This Week in General Chemistry Laboratory. This week we're going to do a couple of experiments with some gases to understand the pressure, volume, and temperature relationships that are found in this equation, the ideal gas law. So pressure times volume equals the number of moles times the gas constant times temperature. So these are the different components of the equation. And so what we're going to do with this experiment is we're going to hold three of those terms constant and look at the changes in the two that we're experimenting with. And so the first experiment, we're actually going to use pressure and volume to determine the ideal constant experimentally. In this, we're going to maintain the moles of gas constant and the temperature constant, and we're going to vary the volume and look at the response in temperature. And so with each of those terms and plotted appropriately, then what we can do is determine the value for n from the slope of a graph. And so that's going to be our first experiment. And then the second experiment, we're going to actually utilize the temperature volume relationship. So what we're going to try to do is hold the pressure constant and the number of moles constant, and then the gas constant is a constant. And so we're going to use this relationship to predict a value that you're familiar with, absolute zero. And so we're going to do an experimental determination of the limiting temperature value. And so we'll be able to graph that appropriately and find absolute zero. So those are the two experiments that we're doing to learn the relationship between pressure, volume, and relationship between volume and temperature. And so, as I said, the first experiment is to find R and to build a graph from our data that we're going to be collecting. And for the first experiment, the apparatus is very straightforward. You're going to need two things. You'll have a box which will have a pressure sensor in it, and so I have that hooked to a GO link. And so a GO link is an analog signal to digital signal converter, and so it allows the software to interpret the voltage response from the gas pressure sensor. And so the gas pressure sensor has a inlet on it, and that inlet is designed for a syringe to seat on there and snugly by turning it to the right. Don't turn too hard because you'll strip the threads. And I'm going to start this experiment by putting the volume to 20 milliliters. So I know the volume of the syringe is set at 20 milliliters. And when I do that, then I'm going to have the software open, and the software is Lab Pro, and I'm going to go in and I'm going to set it for data collection. So I have to find the data collection tab, and I'm going to go in and set it to events with entry. Okay, so when I do that and I have it set to events with entry, my first data point, I'll hit collect and keep, and that's going to be at the atmospheric pressure of the room because I haven't changed the volume. Okay, and so then I'm going to consecutively change the volume by depressing the syringe by 1 milliliter unit, and then I'll hit keep again. And you'll observe that as I decrease the volume, then the pressure will rise in response to that. And so we'll collect that up to the point where the probe hits its pressure max. In other words, the pressure won't change anymore. Realistically, to about the 9 or 10 milliliter mark is plenty of data points. And so you can actually then just remove your syringe, put it back to 20 milliliters, and set it back on there and collect another set of data. And you can do this repeatedly without stopping the experiment. And then when you stop the experiment, you'll click the stop button, and then you can take that data, copy it, and paste it into Excel to process it. And so that's what I want you to do. And then we'll have to do some rearrangement of values Well, we'll have to rearrange PV equals nRT to find the information that we want. And so we'll have to do a little work with that, but we'll practice that as we're processing the data, okay? Now, experiment 2, right? Experiment 2 is to determine absolute zero, okay? And so the way we're going to do that is we're going to set up an apparatus with the pressure sensor. We're going to use it in the second experiment too. And we're going to take a tubing. So we have one of those tubings here. You'll find that in the box. And that tubing has an adapter to go into a rubber stopper, which is here. And then on the other end, it has an attachment for the pressure sensor. So I'm going to hook it to my pressure sensor. Now, we're going to be using a hot plate, and the plastic cords and tubing don't get along well with the hot plate. They melt, and then we have to do repairs. And so be cautious when you're setting this up to, number one, make sure that your pressure sensor, tubing, and cables are away from the hot plate. And so I usually go around the stand and use the clamp to hold those back. And then you'll plug that in. And then on the other hole in the stopper, there should be 2 holes in the stopper. Now some of them appear to have 3, but the bottom is plugged. Make sure that you're in the open ones, because if it's not open to the Erlenmeyer flask, the 125 milliliter Erlenmeyer flask, then this experiment won't work. I actually take this valve out, okay? What I found is that the joints, the more joints you have, the more chance of leaks. And if you have a leak, it really can skew your data. And so anyway, I take the syringe, I put the adapter for the stopper on it, I find the open hole and I put that in. And so then I fill my beaker with water. And so when the beaker is filled with water and it's setting on the hot plate, then I set it up, the syringe on the lowest volume, okay? So I started on the lowest volume, and then I turn the heat on, okay? And so when I turn the heat on, then the heat will start warming the water, and you can even drop a small stir bar in there to help keep that well mixed, and if you would like. And so if we keep it well mixed, then the temperature of the water will raise the temperature of the gas inside the area that it's in contact with. And so what you're going to do in your experiment is raise the temperature. Now there's a trick to this, because these syringes are sticky. You're going to need to watch the pressure on your screen and adjust the volume and to keep the pressure constant. And then about every 1 milliliter, then I want you to hit keep and keep those data points as that gas expands. And so you should have a a volume versus temperature relationship at constant pressure. I'll help you with that, getting it set up, but that's our goal in this part of the experiment, okay? And then from that, we're going to actually plot, right, the data in Excel. So you'll want to export the data to Excel, and we want to use the volume and temperature data, and we're going to graph that volume temperature data in the where we collected it, and then we're going to do an extrapolation back to where it intersects with the y-axis, and where it intersects with the x-axis. And so when we see that intercept with the x-axis, then that temperature should be or represent the absolute zero, all right? Because we can't have a negative temperature. And so anyway, those are our 2 purposes in the lab. You're going to work with your partner today. You can do either experiment first. If you want to modify the experiment, you're allowed to gather enough runs that you can average the data to get better values. And so when you get done, I want you to turn in a graph for each experiment, your lab handout, and answer the questions. Make sure that your graph has the correct units and the axes are appropriately labeled and it's well titled. You'll be graded on that. So safety, beware of explosion hazard when working with compressed gases. Something can blow apart. Wear your safety glasses. And there are no hazardous substances in the lab unless somebody floods the lab in the quantity of water source. Don't think that's going to happen. So, all right, this will be due in a week, and I'm looking forward to seeing you in the lab.